Hey guys, so welcome back to your next class. We're going to continue today with the same trend that we are, and that is looking at different properties and discussing how they are changing for each atom when we go from left to right or up to down. So today we are going to be talking about something called as electron affinity. Okay, electron affinity, AFFINITY, right? So when we say affinity, the word affinity generally means liking towards something or being, I wouldn't say attracted, but having a sort of, I guess you can say attraction, or let's say liking, right? To like something is to have an affinity towards it. Okay, so when we say electron affinity, we are looking at how willing is an atom to take an electron, a new electron. Okay, so we also call this as electron gain enthalpy. Okay, we've seen this word enthalpy in the previous class also, and enthalpy means energy, right? So if you see, it's electron gain enthalpy. So we're talking about how much energy is shifting whenever the electrons are being gained by atoms. Okay, so it is, in a way we can say it is opposite to ionization energy, kind of the opposite. In ionization energy, what we are doing is we're looking at energy required to remove electrons, right? Over here it's pretty much the opposite, the energy you get once you give an electron. Okay, so even for this we are going to be using neutral gaseous atoms. Okay, just like we did for ionization energy, we're going to be using neutral atoms in their gaseous state. If I have to define this, I will call it as energy released when electron is added to the neutral gaseous atom. Okay, so over here, look at the difference. We are saying energy released. Okay, typically it means we are not giving any energy, we don't put any effort here. It's about what happens once the electron is taken. Okay, here what happens, the atom itself is going to give out energy. Okay, that is a sign for us that the atom is actually keen on taking the electron because they want it. Okay, now again that will differ from atom to atom depending on where that atom is. All right, now if I have to write this as an equation like we did previously, I can write it somewhat similar. I'm going to take another neutral atom M. Okay, I'm going to say that I am adding an electron to it. Okay, I am going to add an electron to it. Once I do that, I'm going to get an ion. Now this is a negative ion, or what we call as anions, right? If you recollect, we got cations when we removed electrons. Here, since we are doing the opposite, we are going to get anions when we adding electrons. Plus, I'll just call this as electron affinity, or just EA, like basically the energy that I'm talking about. Okay, now. This would be the general this thing, adding an electron, getting an anion, and then that anion is that atom is releasing some energy. This is the energy we are talking about. Now we can also talk about this in terms of having the second, right? Like how we saw over there, if we take this anion, the one that we got here, and try to add one more electron to it, then what will happen, right? You'll get a double negative ion. It will have 2 minus charge and another form of electron affinity energy, or just energy. We could simply call it energy. Okay, so I'll actually just call it energy or enthalpy more specifically, because electron affinity is a property. So I'll call it enthalpy 1, enthalpy 2. Okay, gain enthalpy, this is what we're using. All right, now there is again a difference in enthalpies. Okay, that will again depend on what type of atom you're working with. For example, say that I have an atom that has accepted an electron, become an anion. Now again, it's an already an anion, we're trying to make it an anion further. So the energy value over here can be positive or negative. Okay, it can be either positive or negative. What is the difference between this positive and negative? So the way I can tell you this is, not all atoms want to take an electron. Okay, they are not all always willing to take an electron. So if the energy is negative, it means that the atom is willing to take the electron. It has taken it up on its own and released energy. So for us, negative is, we say energy released. Okay. And when I say positive, I will say energy absorbed. So this is the energy that we need to give in order for that atom to accept that electron. Because for it to accept and make a necessary changes in this atom and create bonds as per need, it's going to need some energy from our end, because it's not actually willing to do it on its own. So every time the energy value is positive, we say energy gets absorbed by the atom. If it's negative, we say energy is released by the atom or given out, or we can also say liberated. Now, how does this value change in the periodic table? Again, we talk about two ways, group and period. If I look vertically from top to bottom, what happens to these values? Okay, so if I look from top to bottom, I can say that the values or the energy value is going to decrease. Okay. Uh, why will it decrease is because again there will be certain factors for it. We are going to come to that shortly. So when we are going down a group, the energy that is going to be liberated or needed, both of them are going to reduce as you go down. Meaning, for lithium, the affinity will be higher, and for rubidium or potassium, it will be much lower. Okay, how much energy they release or absorb is going to be lower. Now, what about across a period? When I'm going from left to right, okay, so basically, if I look at something like lithium and go all the way to fluorine, which one will have higher? So if I can say that it increases from left to right, okay, meaning lithium will have low electron affinity, but fluorine will have high electron affinity. Okay, that's because they are more willing to take. If you notice, the left side of our table is all metals, right? And these side are generally forming positive ions for us. So over here, we're trying to make them form negative ions. So that is why these metals generally need to be accepting energy. That is why their electron affinity is low. But if you talk about things like chlorine, fluorine, oxygen, they form anions itself, right? So they are more willing to, and that is why they will liberate energy and then give you the ion. So as we go from left to right, the affinity is going to increase. Okay. Now, so what exactly does this depend upon? How can we tell which one has higher, which one has lower, and why exactly that is? Now, we can say that pretty much the same factors that we talked about in the last class. If you remember, we spoke about five things, things like shielding effect, we talked at nuclear charge, atomic size, penetration power. All of these things are going to affect electron affinity and ionization energy also. But more specifically, if I say, the main two things you need to talk about are nuclear charge and the atomic radius. Okay. So if the atomic radius is less, the ionization energy is going to be more. Okay, because small size of an atom, it'll be more easy for it to attract the electron towards it. Okay, so then it's going to be releasing energy. Okay, but if the atom is big, the distance again becomes a problem. Because of the distance, it cannot attract that new electron easily. So as we go increase in atomic size or atomic radius, the energy is going to decrease. Okay. Similarly, talking about nuclear charge also, more the nuclear charge, more easy it is for it to accept, right? If you have more protons, they're more willing to attract the newer electron, right? So more positive charge simply means it is more uh, easy for it to attract electrons. So majorly all five will affect it in some or the other way, but majorly we talk about only these two factors, nuclear charge and atomic radius. Okay. Okay, so that's it for this class, electron affinity and electron or electron gain enthalpy, also how we can call it. Like you said, there are the definition we have two types. I mean, we have the first enthalpy and the second enthalpy. Second enthalpy is generally positive, because once it becomes a negative ion, it's not willing to accept more electrons. So we need to give energy. Okay. And what is the meaning of negative energy and positive energy? That is the most important thing about understanding this energy. Negative means the atom is releasing energy. Positive means we are giving the energy to the atom to make the ion. And the trends. When we go down a group, the enthalpy decreases, and we go towards the right, it increases. Okay. It's kind of in correlation with the metallic property. If you see, if it's metal, it won't be accepting electrons. So if metallic property increases, electron affinity will decrease. Okay. So kind of make that connection, will be simple to remember for you. All right. So that's it for now. If you have any questions, comments, doubt, please drop them in the comments below, and I'll see you in the next class. Thank you very much.